Okay, thank you. So, sorry about that. So yes, I chose today to talk about the role that artists play in the AI revolution. I think it's really important to understand some of the ways that artists work and some of the fundamental metaphors in the technology that they use. So I'm going to talk a little bit about that with some projects. I'm going to show a lot of art, and I'm going to speculate towards the goal of really the program that I'm running, which is the Artist and Machine Intelligence program at Google Research. I'm going to speculate on ways that these metaphors might be helping us change to adapt to a more complex culture in the 21st century, and the way that artists are doing that. And I'm going to push a little bit on the frame here, because there's a lot of really interesting stuff. So I'm going to show some art, I'm going to tell some stories, and then I'm going to sing a song for you guys. So let's start. Artist and Machine Intelligence exists within Google Research. We're a very small group inside of a larger group of about 150 people. So there's maybe 4 or 5 of us working at a time on it, but not everyone is full-time. Our goal at AMI is to bring artists in to work with AI researchers to develop projects using AI. So we do that in order to change the direction of research with artist feedback. We do it to develop a rigorous public dialogue around artificial intelligence. And by rigorous, I don't mean strictly technical. I mean culturally rigorous. And to develop an emergent practice of artists working with AI and collaborating with engineers and with intelligence systems themselves. But one of the reasons I think this is really important is because there's been some research recently that shows that tool making has had a profound impact on the human brain. So if you take a look at this hand axe, which is a 300,000-year-old tool, there's some research around the process of making these tools by Dietrich Stout at Emory University that's shown that the actual process of creating them so he's done neuroimaging tests with people that are actually making these hand axes in the traditional method, and it's shown that there's a change that happens in the brain in the process of doing this. The actual architecture of the brain changes, and the areas of the brain that change are the ones that are associated with communication, using gestures, and perhaps even language. So in short, what he's saying is that tool making produced structures in the brain that got co-opted and became what potentially spoken language today. So the tools that we make and the tools that we use are actively changing who we are. So if we think about some of the trajectory of representational image making, we can start with perhaps this digitally reprojected image of the anamorphic skull and Hans Holbein the Younger's painting, The Ambassadors. So the actual painting looks like this. The skull, when digitally reprojected, looks like this. The reason it needs to be reprojected is because it was actually done with a lens. So we can consider that photography actually began with this type of painting, moved on to daguerreotypes, conceptual color photo-based practices like Ronnie Horn's, and is now moving into a space of using big data archives to generate images from neural nets. And I'll explain what that means. It's a technique called hallucination. I'll go into some detail about that. But the gist would be hand, lens, film, CCD, big data, neural nets. This is an image of a 12-dimensional hypercube that I bought from the outsider artist Vince Rourke in Kansas City, Missouri. He received shock treatment for shakes that he got when he quit smoking and started having out-of-body experiences where he saw these forms, and now he paints them. Hyper shapes will become an important part of this lecture. And this image is called trippysquirrel.jpg. This is the canonical first public Deep Dream image. It was leaked to Reddit. So if you're familiar with Deep Dream, it's the hallucinatory neural net technique I'll be discussing. This image leaked online, and it compelled Google Research to publish Deep Dream. And I'm going to talk a little bit more about that in a second. But the point I'm trying to make with all this is to say that the tools that we create change our mode of cognition, and they change our actual brains. The representational tools that we're using are increasing in complexity because of AI. And AI representations are highly multidimensional. So I want to ask, what new cognitive mode will AI produce in our neural structures and in our experience? So let's start with hallucination. This is another deep dream image. Have you guys seen this imagery before? Yeah? So this came from a show that we did in San Francisco. But as I said, Trippy Squirrel was released. The Google research team ended up publicly promoting it because it was going viral, and they needed to address, like, what are these bizarre hallucinatory images that are coming out of Google research. This is a deep neural net. The technology that creates these images comes from this. I had to put it sideways because it's so long. But deep neural nets have thrived recently because of advances in GPU processors that were made for video games. It's vector math, so things that were made to render vectors in video games can actually be used for AI. The way that we produce the neural nets that we use is by training them with massive corpora of labeled images. So you can see some examples here. And this is an image recognition system that's used to identify objects with computers. So you can hold up a phone, and it'll say that's a dog, or that's a cat, or a plant, or whatever. This video shows a little bit about how that works. This is image recognition with a neural net. That's a bird. So if we run that same process backwards and decide to generate a bird, we'll see something that looks like this. So we start with the label, and we end up with an image rather than starting with an image and ending up with a label. But that doesn't quite look like a bird, right? It looks bird-like. But it's not the canonical image of a bird that we have in our minds, because that's not how the computers see. They look for features that indicate birdness based on the training data that they've received. I'm going to get into a little bit of math, but I think this will help understand the larger point that I'm trying to make. As you can see, there are two cubes up there. Inside of each are filled and hollow dots. With a neural net system that tries to recognize images, what it does is you need to create linear separability between the two different types of things here. So the labels would be filled and empty. If you have things that are clustered in such a way that you can draw a straight line, you have a very simple formula. If you have things that are clustered in a way where they're penetrating into each other, you need to start creating a curve. It's a little bit more complicated. If you have a highly multidimensional space going beyond 3 dimensions, and as these neural nets do, end up sometimes millions of dimensions, you need to create essentially a folded hyperplane that moves between all of the different shapes. How do you do that? You do that by training a neural net. And you end up storing it as a series of numbers connecting nodes in the neural net. So you're weighting these numbers. They're called weights. And you're essentially creating a high-dimensional surface that's folded in this strange way and stored inside of a network as numbers. Okay? So the point is, you're creating this thing that we can't even really imagine at all because it's so multidimensional. Like we do pretty good with 3D space. We can kind of sort of conceptualize what 4D space is, but like 500-dimensional space is completely unfathomable, right? It's a little bit like this 12D hypercube that Vince Rourke saw after he got shock treatment. Or this. So back to the show at Gray Area. This show was the first of its kind. We showed a bunch of neural net artwork, things that were generated using hallucination. This image was in there. This piece by Memo Acton of GCHQ in London called All Watched Over by Machines of Loving Grace. And we also did some work with a Butoh dancer where we projected onto her as she danced. recently, artists like Constant Dullart, who might be considered more of a traditional contemporary conceptual artist or a new media artist, have been using Deep Dream as well to investigate the intersection of certain technical and cultural infrastructure. This piece is a visualization of the bubble class, so it's a hallucination of the bubble label. And it was fabricated by oil painters in China, shipped to Los Angeles, where it was car-coded and shown at Nicodeme Gallery. So the technology is getting kind of absorbed into practices that touch other aspects of culture. One artist that we did a project with that is doing something maybe similar in terms of investigating the relationship between AI technology and various aspects of the technical and cultural infrastructure that surround us is Ross Goodwin, and he does work hallucinating language. So this poem, white clouds in blue sky spread out on the road, and in the storm there was a silvery star-like streak of sleeping children. A pair of jeans were still on the table, and the long black stains of hair shone in the cloud of flowers. That poem was written by a neural net. That was a hallucination of text, just like the images that you saw previously were hallucinations of image systems. This is a hallucination of a text system that's been trained on millions of words. It was written by something called WordCar, which is a construction that Ross created out of a rental car, a surveillance camera, and a neural net. We drove the car from New York City to New Orleans, and in the process, it generated 200,000 words of quasi-nonsensical AI poetry. Red and white flags, and the stars were like a curtain of paper, like a broad stream of flowers. The thing that's being described by the neural net is the image coming from the surveillance camera. It's also rendered here as ASCII text, so there you have an image and you have the poem that goes with it. This project was, as I said, it investigates certain intersections of technology and culture. So the way that the poetry was seeded was with a timestamp, a GPS location, or Foursquare data around the GPS location. And so the things that it saw, the senses that it had, were fundamentally techno-capitalistic, let's just say, in terms of all of us driving down a decaying industrial corridor surrounded by fast food restaurants accessed via the Foursquare API to write poetry. I mean, this is what the machine sees, right? So we anthropomorphize AI a lot of ways, but right now what is available to AI is in its senses is fundamentally structured by the needs of industrial capitalist culture and food distribution in this case. So Hard Rock Hotel and Casino Biloxi, a hotel in Biloxi, a high fisherman with a starry face and a stub of a coat on his face and his shirt looking boldly across his mouth. This was largely considered a literary journey by Ross, and I encourage you to read the essay I wrote about it, which is on our Medium blog, AMI's Medium blog. It touches on some of the precedents that inspired Ross. So in order to get to this point of experiencing high-dimensional spaces, which is what's really happening when you look at a lot of this work, you're looking at a linear pathway through a highly multidimensional space. In order to really have that experience, we have to reduce these things down into 2 or 3 dimensions. So the way that we do that is something called TSNE, T-stochastic neighbor embedding. We did a project with Rafiq Anadol. He does projection mapping. Here's some of his work at the Disney Concert Hall in Los Angeles. We worked with him at the Salt Museum in Istanbul. So Mike Taika, my colleague, wrote some code that he used in an immersive installation that shows the 1.7 million item archive of the Salt Museum. Here's a rendering of the architecture. You walk into a corridor. There's a circular room with a fully projection mapped interior. There are mirrors on the floor and ceiling, so it creates an infinite column of light and images. And inside, you see images from the collection organized through the features recognized by the neural net and the AI and clustered like that way. So you can see the images are similar in both of these photos. It's not using necessarily metadata to do that. It's using features of the images themselves. And you can navigate through them and sort of use it as a research tool as well as an immersive installation. This is where you can see a 3D visualization of the high-dimensional space of all those images and their interconnectedness. So to zoom in a little bit, you can sort of see the clustering, and they're spatialized using this Tisney technique. You can see some of the features of the images here being linked to each other. And actually, Mike implemented a hallucination technique to visualize images that don't exist in the archive but are statistically likely to or could. So one mode of experiencing this installation is looking at hallucinated images that don't exist in the archive. So I'm going to take a break from showing art and talk about some research that my director, Blaise Guarriarcas, did around gender as a multidimensional space. This is something that he did outside of his capacity as the director of our group at Google. It was a 65-question survey that he used Mechanical Turk to get answers for. It had questions about body, presentation, attraction, and identity. I'm going to talk only about the body and presentation questions. So there were things like this that are very anatomical, let's say. And then there were several more questions that were about cultural representations of gender and presentation by individuals in society. These are the results. I'll walk through it a little bit. There is something of a binary in the output, but there is also a spectrum. And when we use a higher dimensional Tisney technique to visualize the output, we have something much more complex. And we can visualize something much more complex than even a spectrum. So, if you use something called singular value decomposition, you basically create like a single value and you get a number for that. That's where you get a quasi-bipolar representation. There still is a middle. This is using the body data only. Using the presentation data, you still have, there's no excluded middle, but you do have peaks. You do have binary peaks. And then if you look in higher dimensionality, you can see that there's a lot of movement across the space. And you have generally a clustering in two poles, but you can see more of the depth of the movement across the space. So this is, again, the body as the principal component, the presentation component, and then them together. So sex and gender are a whole vector space, rich in both obvious and subtle patterns, non-conforming, more detail about the study, but the basic gist of this is when we take something that is sort of being deconstructed culturally right now against its previous binary framing and put it into a multidimensional space, we have a tool for thinking about something that could be much more productive of identity and subjectivity for people that engage with it. And so what I'm driving at here is that artists are leading the forefront of multidimensional thinking through creating experiences that guide us through multidimensional spaces. So I'm going to close by talking about how we might be able to employ this type of multidimensional thinking within our own lives as individuals. I was telling my friend Sam Winiger, who's a creative AI technologist and artist, about a song that I heard, which I'm going to sing for you. And what he said was, how are you going to be mad at someone in a manifold? So to really understand what that means, we need to look a little bit at knot theory. This is something that knot theorists, which are people who try to classify knots, call the unknot. It's the simplest knot. It has 0 crossings. It's a loop. Even if you fold it over on itself, it's still a loop. It's the unknot. The next knot has 3 crossings. It's called a trefoil. The interesting thing about all knots is that a 3-dimensional knot in 4-dimensional space is untied, essentially, always, just like with linear separability. So a way to imagine it is if you go from, instead of going from 3 to 4 dimensions, go from 2 to 3. Imagine this circle inside of this rectangle. If we try to move it out, they will touch. There's no way to move them out without them touching. But if you put it in 3 dimensions, all you do is lift the circle up and move it away. It becomes a much simpler situation. Like with linear separability. just on for a few dimensions here. So the way that I relate to this as an emotional or psychic or psychological aspect of life is to think about this early Polynesian framing of illness, which is that illnesses were caused by emotional or psychological or psychic errors that could be untied. And there's something here in this book by Douglas Oliver describing an untie error right. In Hawaiian culture, there's a word, ho'oponopono, which means to put to rights or mental cleansing. It's a process and it's a word that essentially provides a higher dimensional model for a relational situation that in a linear model of victimhood, guilt, forgiveness, and love would be much more difficult to navigate through. So what I'm trying to get to is that this multidimensionality, when we view it as a relational aspect of our lives, can be felt and lived through these processes that have already modeled tying and untying, which have a certain built-in topological function. So we can become much more like the unknot in that process, or even like the fool. So here goes. Ho'oponopono, 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 ho'oponopono. I love you. I'm sorry. Please forgive me. I thank you. I love you. I'm sorry, please forgive me. I thank you. Ho'oponopono, 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 ho'oponopono. Thank you.